Systems of linear equations. Now what this is, they consist of multiple equations. In this class we're just going to do two. And solutions satisfy not only one equation but every equation in the system. So look at this example. Some books write them like this, so you know that these two are grouped together as one single system. Now we're going to determine if these 2 points are solutions to this system. Now if you remember anything about points, these are always x comma y. So this is our first point. We're going to test it into the system, which means we got to test into both equations, not just the first one, but into both of them. So when we substitute them in, we're trying to see if the left side is going to equal to the right side. Let's find out. Order of operation states we multiply, and we end up with -4, which is definitely equal to -4. So it worked for the first equation. Now let's try the second equation. This was for 2x plus 3y equals -4. Now we got to try it for y equals 4x plus 8. Same point. Still in the same point. So our y value is 2. X is -5 plus 8. 2 equals, does 2 equal -20 plus 8? Well, -20 plus 8 is -12. Does it equal 2? No. Since it didn't satisfy one of the equations, what that means is that -5 comma 2 is not a solution to the system. Let's try -2 comma 0. Let's see if it is. So let's test it into both equations. I'm going to go ahead and write those down. We're now doing 0 or -2 comma 0. Let's substitute -2 comma 0 into both equations and see if a true statement is yielded for both. Remember, x is -2 and y is 0. That's why I'm putting the numbers where I am. 2 times -2 is -4, 3 times 0 is 0, -4 plus 0 is -4, and -4 does equal -4. That's good. That one checked out. Y is 0, 4 is -2. Let's see if both these sides are equal. 4 times -2 is -8. Bring down the plus 8. -8 plus 8 equals 0. That one checked out. Since they both checked out, that means that -2 comma 0 is the solution. This is the one that is. That's how you check it. Now, the real question is going to be, how do you find the answers? How do you find the solution if there is one? There may be more than one. Before we go on, there's some words you got to pay attention to. A consistent system is a system that has one solution. This is a consistent system because it had exactly one solution. If it didn't have any solutions, it would be called inconsistent. And if it has an infinite number of solutions, which basically means that each of these equations are the same, I mean that look like they are, but they are, then that's called a dependent system. So we got two main processes on how to solve. It's actually a third, but we're going to just stick with these two. One is called substitution, which can be found in 14.2 of your book. The other one is the elimination or the addition method. It's the same thing. That's found in 14.3. Substitution is basically what it is, what you think it is. You're going to substitute one equation into that other equation. So we're substituting entire equations into the other equation. Elimination or addition, we'll come back and talk about that one later. Now let's solve this first example. Some books use parentheses around the system. That's what I tend to do. Now when you look at this, you'll notice we have two equations. One of them, the second one, has already solved for x. So we know what x is. It's actually equal to -3y plus 3. So what that means is, I'm going to take the first equation, and I'm going to substitute x with what the equation that it represents. In this case, -3y plus 3. I'm going to use parentheses to show you what's going on, to show you the substitution. X is now -3y plus 3. I just bring everything else down. So what I end up having is a single equation with a single variable that I can solve for y. I'm going to go ahead and rewrite it without the parentheses just to show you. Just a standard linear equation. Going to combine like terms on the left side. -3y plus 4y is 1y, or just plain y. Going to bring down everything else. Going to isolate the y by subtracting 3 from both sides. We end up with y equals 3. Now, a lot of people will miss this problem because they think they're finished, but we're not finished. Anytime you're solving an equation and you end up with a y equals or an x equals, that's just part of the answer. We also have to find the x value because we're looking for ordered pairs or points, and they're always of the form x comma y. There may be some other cases where we don't always end up with a single point, but anytime you can solve for one of the variables, you always got to find the other variable. So in this case, I got to find the x. Now, to find x, I could substitute the 3 for the y in the first equation. I'll go ahead and label it first. Or in the second, it doesn't matter. But I'm going to use the second one because it's easier. Now, if you use the first one, you get the exact same answer. And I'll show you that verbally after I find x using the second equation. So, I'm using x equals negative 3y plus 3. And know that y is equal to 3. So I'm going to substitute it into the y. I'm going to simplify this. So I have negative 3 times 3 is negative 9, and negative 9 plus 3 is negative 6. So the answer to this system is the ordered pair negative 6 comma 3. Now let's use that and check our answer to the equation. So I'm going to write it up here, negative 6 comma 3, and just check it. So if I were to take negative 6 plus 4 times 3, another 4 times 3 is 12, and negative 6 plus 12 is 6. Let's check it down here. And now if I take the negative 3 times the y, which is 3, negative 3 times 3 is 9, negative 9, and negative 9 plus 3 is negative 6. It checks out in both equations, and I'm done with this problem. Now let's do the second one. Let's see if it's any easier. Maybe it's more difficult. But I can already tell it's more difficult. We're going to do substitution. The reason why I know it's more difficult, neither one of these is solved for a variable. So I got to decide, do I want to solve the first equation for x or for y, or do I want to solve the second one for x or for y? If you look at it, if I solve for x or y or x down here, I'm going to have fractions roaming around. It doesn't matter, but I don't like fractions, so I'm going to try to stay away from them. I'm going to solve the second one for y. The main reason is it doesn't have a coefficient other than 1 in front of it, which means I'm going to avoid fractions. There's all kinds of ways of doing this. I want to do it one way, but I probably shouldn't. So I'm going to do it the way most people will. So I want to get the y term by itself, which means I got to subtract the 2x. We're going to bring down the negative y, don't lose that minus sign, equals negative 3 minus 2x. Doesn't matter how you write, which order you write it in. You can think of that as a negative 1, so I'm going to divide each individual one by negative 1. We get y, positive y equals positive 3, a negative divided by negative is a positive 2x. Now what I'm going to do is, I'm going to take this y equals 3 plus 2x, and I'm going to place that into 3x plus 5y equals 2. I'm going to place it into the other equation, which means everywhere I see a y, I'm going to replace it with what it equals. Y is equal to 3 plus 2x, so over here y becomes 3 plus 2x. The whole idea is to have one single equation that consists of both equations but only has one variable, or has a like variable, because then I can complete it like I normally would when it comes to solving equations. So I take 3x, distribute to 5, and you get 15 plus 10x equals 2. Add the like terms, 3x and 10x is 13x. Going to isolate the x term by subtracting 15. And now I'm going to isolate the x by dividing both sides by 13. And we get x equals negative 1. Now I'm not finished because, once again, I got to have an x part, which I have, but I also need the y part. So that means we got to find y. Now, when I find y, I'm going to substitute x equals negative 1 into an equation. And the one I'm solving is this one right here. I can substitute into this one, but if you look, I've taken the second equation and I solved for y down here. That's what I'm going to substitute x equals -1 into, because it's the easiest thing to use. And it's the exact same as the equation that's in the system. 2x minus y equals -3. It's the exact same. Which means that I end up with the y equals 3 plus 2 times -1. 2 times -1 is -2, and 3 minus 2 is 1. So our final answer is -1, comma, 1. That's our final answer. -1, comma, 1. And that's how we do substitution. Now let's do elimination. See if we can find an easier way. A lot of people like elimination more so than they do substitution. It's a lot less work. Now with elimination, there's only two things you're allowed to do. You can multiply by a constant, which is just a plain old number, or you can also add the equations together. Nothing else is allowed. So let's see what we have here. The first thing you always want to do when you're given a system and you're using elimination or addition, same thing. If you happen to add, does it eliminate anything? You know how they say speed kills or addition kills? We want addition to eliminate. And if we were to add our like terms, 3x plus -3x, if we were to add, those will give you 0x, which is what we want, because that basically means it's gone. So now when we add these two, 4y minus 5y, that gives us -1y. And then we add -2 plus 1, we get -1. That's a lot easier to do without having to substitute everything. Because now, when we divide both sides by -1, we have one part, or one side of the answer done. Y equals 1. And now we're going to substitute, because we need the x, we're going to substitute y equals 1 into one of the equations. It doesn't matter which one. They're both not nice. So I'm just going to pick the first one. It has less than negatives. And so I'm going to end up with 3x plus 4 times 1 equals -2. Think of this as a review of solving equations, because that's basically what it is. If you can solve the linear equations, you can do these. So I'm just following the same steps as I normally would. Everything I'm doing is trying to eliminate the x, or trying to isolate the x. We end up with x equals -2. We had x equals -2 from y equals 1. That's our answer. -2, comma 1. Now the next one isn't near as easy. I'm not gonna lie to you. Not even close. Because if you look at these and you try to multiply, or try to add I should say, nothing's eliminated. That gives you 5x, that gives you 15y. It's not good. So now we got to use what we're allowed to do. Multiply by a constant and add the equations. We got to multiply by a constant first. Here's your whole thought process. You got to decide, do you want to limit the x's first, or do you want to limit the y's first? Let me show you a different way of doing these. We're actually going to eliminate both of them. Some people prefer to do it this way. Let's say that we choose to eliminate x's. In order to do that, we gotta look at the 2x and 3x. What you really want to do, you want to think of the LCM. LCM is the same as the LCD. What's the smallest number that 2x, or that 2 and 3 both divide into? And the answer will be 6. What that means is we need each of 2x and 3x to be 6. One of them must be a negative, because when we add, they got to cancel, which means that we need opposites. They're both positive right now. So in other words, here's what's going on. We need to change 2x to 6. In order to do that, the only thing we're allowed to do is multiply by a constant. So we're going to multiply the top equation by 3. But on the bottom equation, we need that 3x to become not just a 6, we need it to become a negative 6. So what you multiply 3 by to get a 6? 2. How do we make it a negative? We're going to multiply the second equation by a negative 2. That's our thought process. Think LCMs and always remember opposites. So when I say multiply by 3, we're going to multiply everything in the equation by 3. 3 times 2x is 6x. 3 times 6y is 18y. 3 times 7 is 21. We're going to multiply each one of these terms by negative 2. Negative 2 times 3x is negative 6x. Negative 2 times 9y is negative 18y. And negative 2 times 10 is negative 20. I should have the paper up. Now we're going to add 6x plus negative 6x is 0x. 18y minus 18y is 0y. And then 21 minus 20 is 1. Now 0 times anything, 0 plus anything, plus another 0 is 0. In other words, a bunch of zeros over here. So here we come up with a different kind of result. 0 equals 1. Does 0 equal 1? No. Will it ever equal 1? No. The answer is no solution. Anytime you get a false statement, it's no solution. This is called an inconsistent system. So, just be aware. It's a possibility. Now let's do these last two. This time I'm not going to tell you what to use. What you do is completely up to you. But hopefully you'll be able to recognize what to do. On this first system, if you take a good look at it, one of these is already solved for y. That kind of tells me I'm going to use substitution. I'm going to substitute the second one into the first one for y, because it's already y equals. So I'm going to take the first equation, I'm going to replace the y with what it is equal to according to the second equation, which is x minus 3. Now be careful here. Got all x's, which is what we want. We're going to distribute the negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12 equals 8. 4x minus 4x cancels out, leaves a 0. You end up with 12 equals 8. Is that a true statement? Nope. No solution. Inconsistent system. Let's look over here. Would you want to do substitution over here? I left out a y. Let's put the y in. No, you wouldn't want to. Because if you solve for any of these for x or y, let's change that to a y. You're going to have fractions. We don't want fractions. And we can't add as they are. So we're going to have to make a decision here. What do we want to do? I want to use elimination or the addition method. Either way, either name is fine. So we're going to use elimination. Now I choose to eliminate the x's first because I think they're easier. It doesn't matter though. Now if I eliminate the x's, I need to find the LCM of negative 5 and negative 15, which is 15. I'm not worried about the signs as of now. Well, one of these is already a 15. In fact, it's a negative 15. So what that means is I need to change that negative 5 to a 15. In fact, I need it to be a positive 15. So 5 times 3 is 15. But if I multiply it, that gives me a negative 15. I need it to be an opposite of this one. So I'm going to change that 3 that I'm going to multiply by to a negative 3. Because when I multiply, a negative 3 times negative 5 is positive 15. That's what I want. Positive 15x. Which will cancel out with this negative 15x. So there's two things you got to remember. I need these to be the same, and I need them to be opposite. So I'm going to multiply this throughout, and we're going to have new equations when we do that. Negative 3 times negative 5x is a positive 15x. Negative 3 times a positive 9y is a negative 27y. And negative 3 times a negative 7 is a positive 21. Now, we're going to bring down the other one as it is, and now we're going to add. Those cancel, leaves a 0. And a 0 equal. Now when you add these, 21 equals negative 21, what does that equal? 0. Once again, I mean, you may not be able to see that. When you add these together, you got a 0. When you add these together, you get a 0, which means you get nothing but a 0. When you add these together, you get a 0. When does 0 equal 0? Always. This has an infinite number of solutions then. Anytime you get a true statement like this, I mean it's always true, it's infinite number of solutions. This is called a dependent system. Dependent. And so just be aware. You may get no solution, you may get one solution, you may get an infinite number of solutions. But that's how we do systems.